Mhm. Mhm. Let me refresh it. So we are live. We still have like 3 minutes before we proceed. I will just check. Hello, hello. Let me refresh it. Yeah. So this is working. This is something I want. We will start at 12:10 as we said earlier. I am just refreshing. Mm-hmm. Hello, hello. Let's take it here. Oh, that's a good thing that I checked. Let me change to the setting. So visual is looking good now. And how to mute this one? Why can't I? Hello, hello. Hey. How do you mute this? I think there's a delay. Hello. Okay, so this looks promising. I'm just keeping it. So I'm using my phone to see if somebody join our chat or they want to ask a question. So I don't have to fumble between the screen. And I think it's 12:10. We're gonna start today. So hey everyone, welcome to the day 10 where we are covering the PostgreSQL from basic. My name is Nathan and I welcome you all. So today what we're gonna cover the few things that is left from previous day and we're gonna cover it in terms of practical as well. That is table constraint. And second one that we're gonna cover today is table modification and that's really important as well from the senior perspective or even when you start working as a SQL developer or you're using SQL for your development, it's really critical to use it. Perfect. So before we go proceed, do you have any doubts if someone? Okay, so there's no doubts, so we can quickly move. So before we move, let me quickly tell you the links that's really important and critical. First one is my LinkedIn profile. Simply go and follow it. Second, the most important is GitHub repository. After that is Gumroad, where I'm going to keep my articles and item that I want you guys to have specifically. So here you go to SQL. Here the fourth directory, the fourth one equal to hero from 1 to onwards is like sequential order of the topic related with the Postgres as a relation database management system you should follow. And it will really helpful for you to understand from end-to-end perspective why the SQL came in, why the relation database management system, what is database, what is scheme and all those stuff, and how it is carried forwarded. So it's a very structured way I'm trying to do the things. So constraint here I already created, but we're gonna learn more in depth using uh, Postgres SQL, your relation database management system, and this tool as well, work queries. So let's do it. Okay, perfect. So let's see, let's activate our server. Yep. All the database has been connected. Establishment is done. So we are good on this one. So this is the first thing. Second most important thing is the reference. So remember, you should always refer to the official website in case goes wrong. You know where to look after or to whom you need to reach out rather than randomly learning from the internet. So we are on the data definition where we define what kind of data or information or attribute about the entity we're gonna have in our system. So that's why it's called data definition, because you define what kind of a data I can allow, what kind of a data I want, what kind of a data is being filtered through into my system. So the best part of doing this is not constraint, but the very first is data type. So when you define a table, remember in a system, when you define that in a system here, I will have one schema, a segregation where I will have all the data about the student. Okay. So this storage is nothing but your database. Suppose it's a building. Okay. This building is your database. The one who operate on this one, the manager, the operation manager is nothing but your relational database management system. Okay. And he work on this one based on the request you send. Therefore, you need, this is you. This is the request you send, and then he works here and then get back to you. Perfect. And that's why this request and the working mechanism, request and response working mechanism, and that's the reason the Postgres SQL work on the architecture or model of client server. Your client send a request and this person work for you. Since this is the reason, this is your database, this is your schema, and here you will store all the tables or related tables. Perfect. All the related tables here. So now this is the structure. Okay. If there is a table, that means I can store information into it. I can store data inside it. Is it correct? Perfect. Can I allow any kind of a data? Let's give an example. Today you constructed a building and now you created the floor, and each floor is for particular group of people. For example, in the first floor you kept lawyers, second floor you kept engineers, third you kept the CEOs, and fourth and one is for content creators. Okay, so that means you segregated the floor based on the occupation, and this segregation within a database is called a schema. Technically, not exactly, but yes. And you see, when you stack up all the flows, what you are constructing database without even single schema. Can a database exist? No. That means database is nothing but a blueprint or the process of creating schemas. Creating the process of creating database itself is a schema. Or a schema is the blueprint of your database. Right? And inside each flow, you create different divisions, different design based on the requirement. On that designing, like how you gonna hold the data. Like suppose in here you have lawyer, you saw like there are 10 lawyers. So you created five how the room based on that requirement. Right? Exactly, that's exactly this define our data definition language. That means it help you to design your scheme. But underlying meaning is it gives you the leverage to enforce rules, like why we want to we define the rules which enable us to filter not required column, required data. Or in a simple words, this rules enable you to get only the data that is legit and required as per your requirement. Best example is the age. Okay, no, here. Suppose I created the database for university, and one of these floor is for student, or one of the schema is a student, right? A student. Now, in that student schema, I am trying to create a room or the storage for student details. So here I'm going to student personal details, personal details, right? Here I'm going to put all the information about the student's personal details, right? For example, name, age, address, and university ID, right? Can at a given point of time this name can be integer? No, it has to be text. Age, it should be integer, cannot be text. Address, it has to be text, cannot be numeric. This has to be int because it cannot be text. Again, it cannot be boolean as well because there can be multiple table. So the very first rule that I add on what kind of information I can accept for the entity that want to come into this storage is the information type. First rule itself is data type. That is what kind of a data I'm going to hold into that table or into that room. Okay. Now, at times we need more than that. Let's take an example of age. Can a student have the age 0? He never born, but you enroll it. Is it possible a student can have age 0 or a student can have age 18 negatives? No. Can age be thousands of years old? No. People or students love to brag a lot. They can fill this information. That means for age, first rule is it should be integer. That should be whole number, right? Second one, it should be over 18 and less than 50s, right? That means I need another rule that define that the information is legit and is permissible to be inside this room, inside this table, inside this storage. If the entity information about the age is greater than equals to 18-year old or he is less than or equals to 50 years old, right? That means we define a rule to simply age should be greater than 18 and the student age should be less or it should be less than equals to 50. This is the second rule that define. If it is not followed, that means I cannot insert the data. It's not a legit data. It's not legit data about a student, so it need to be dropped off, right? Third thing that you can define at given point of time. Can this value be null? That means there is a student or there is someone who claimed to be a student, but he does not have a student ID. That means he does not belong to any of the university. Answer is again no. That means we need to define it that it cannot be empty at given point of time. That means rule number 3, that is university underscore ID cannot be not null. Null represent emptiness. That something is empty or not provided or missing or unknown, right? This is the thing. Not null means that it cannot be empty, it should have a value. And what kind of a value? It should be an integer. Now, can it be negative, positive? It doesn't matter. Reason is very simple because this ID, that means there should be another table that holds the information about the university and there should be an ID about that one, right? So this ID is linked to this one. That means this ID that is provided to a student will be a legit ID if it is present in the university catalog. That means there is a legit university. If not, that means this cannot be inserted, right? So I can create one more rule, fourth rule, that student ID is legit. Rule 4 is it is legit and will insert after following rule 3 and at the rule 4 that the this ID, that is university ID, exists in university paper. That means there is a legit university available, and if it is available, that means this student is a legit student enrolled in that university. And this kind of a relationship or rules or this kind of constraint, we can do it using foreign key concept. Perfect. So there are many kind of constraint that we learned yesterday, and I will be really quick. First one was let me clear this first. So firstly, let's go here. Check constraint, not null constraint, unique constraint, primary constraint, foreign constraint, and exclusion constraint. Exclusion, we need to read it again, but these are the four ones that we learned. So yesterday we already covered check, then not null we already covered, unique we covered, the primary key we covered, but we're gonna do today in terms of practical. We're gonna create table and going to put all this together. So let's quickly go back here. University, I think student here. Dude, one thing I should do is save all the files because I saw like I am missing the information. So let's quickly run this. This application is lost connect. Okay. Now let's quickly check where it is failing. So it is failing integers, line number 10. So see, I'm doing this one online because I haven't prepared because once I started doing this way, you will realize what kind of error people usually get because most of the people nowadays they show you the perfect thing, but that's not how things work. Even the person who is working for years may make mistake because you learn so many things. So you might like for example, the day before yesterday, I was using serial rather than the sequence because sequence was the right keyword for sequence. Serial is for sequence is from the whole Python, and I got confused that there might not be any keyword in SQL, but it indeed indeed there is. So let's quickly go. So this way, I will also teach you if you find any error, how you need to debug, how to route it back or trace it back to the root cause. So you see the error is number 10, less we saw it. And what is the error? If and not null check. That means what? And there's a syntax error. Let's see. Error syntax error. Around the line number 10. Let's go. 10. But see here. I did have this one check. Okay, let's what okay, check. So basically what is happening here after check, there should be a condition that should be fulfilled in order to check the validity of the information provided for a student, right? That means the age should be legit. But the problem is this expression is missing and he's looking for that expression. That's why it's a syntax error. What we're gonna do, I'm going to recreate this everything so you guys understand that I will remove this one. If I run it, it will run properly. Okay, there's another error. What is the error? Error, syntax error near this one, line number 16. Where is 16? This is the 16. And okay, so you see here, I told you that when we define the column details here, the last column should not have comma because that is being enclosed by this one. Okay, other column is being enclosed or is being ended for the command by comma, but the last one will be done by parenthesis. See, it ran. So now I will start again, and this will enable you to understand how things work. So today my manager comes in and asks me that Nathan, you need to create a table for a student inside a database university. Okay. So what happened? There is no database for university, right? So let's create one database for university. Uh, create database. See, I told you SQL is very English-based language. That's why it's called declarative language because you declare everything in English, and it become really easy to and everything, the complex thing, operation, everything is handled by the engine or your RDBMS, so you don't have to worry. So create database. Database is university. I'm creating a university database. Let's see. Will it create? So now it has successfully created. So first thing is done. And can I see it here? No. Answer is because this is GUI. It is always a static. It is updated based on the last request I sent. Now let's refresh it. It should be there. Now university is there. That means I can take this off, correct? And see, there is uncolored. That means it's not connected so far. So I will first close this. Save. No, let me save it. Don't save it. Don't save it because I'm going to start everything from start. So now once click it, it automatically connects. So remember, every connection connects to single database. Okay, inside the database you can create another database, but if you want to access other database, then you need to follow proper procedure. So here you see schemas. I told you database is your building. Okay, building that we said this is the building. So you see what happened. So at the start, okay, this is the ground. Okay, this is the ground. You came here and were like, I'm going to create my building here. Is there any building? No. Is it database? Right now, no. It's just a plot available for construction. And the person who going to construct it is your operation manager, RDEMS. I will tell him, can you create a university database for me that I created? Like create database. Database name was university. He will go, he will cut a plot for university. Okay. This is the plot I'm reserving for university. University. So now all the construction that gonna happen in this plot. Okay. This is reserved, but is it a database? No, it's just reserve the space. Now what I did, if you go here in the schema, there's a public because a database is nothing but a collection of a schema, right? That means it should have at least one floor. Then only you can say he will create here. He will create his first. So it will be like this. This is the plot for university. But the first floor itself is created by default. That is public, and this floor is nothing but a schema, right? And this is database. So the database university will have automatically first schema, first flow created by default for entry. This is called public schema. It is always there. It's gonna happen everywhere, every time you create a database. By default, they will create one schema. That means a database came into existence along when there is a schema. So database cannot exist without a schema. That's why you can say database is nothing but collection of a schema. And schema, what is a schema? Schema is nothing but a collection of relatable data sets. What kind of a data set? Tableau data set. Okay, so here it is. But do I need to use this one? No, I want to be more specific because I want to create one floor for student information, one floor for professor information, one floor for finances. That's why the modularity comes. It becomes very convenient to divide the data. Accessibility become better, security become better, your understanding about the architecture become better, and it become more organized in terms of data storage. Okay, so that means I need to create one floor for my schema, but how? We need one query this one. So I will go here, right click and query tool. Now this gonna act as my query. Now this interface is nothing but my way of talking to this guy. Okay, so when I talking to you, what I'm doing, I'm using English as a language to communicate with you, right? But what exactly I'm using my mouth and the sound that I'm producing through my thought. That means there is these two machine or devices that is helping me to deliver this message to you. Okay, the message is English language, the message is in English language. Similarly, this guy cannot talk to this one because this is a virtual thing. This is a software. Okay. To communicate with him, we need a device. And this device is nothing but either can be client CMD or it can be some GUI. And currently the device we are using to throw our message or to deliver a message to this one is this guy, this PG admin. Okay. And the language that we are using to send our message is SQL, structure query language, that we are using to communicate our message. What message we are sending? There's something depend on our requirement. Like for example, initially it was one building. Okay, I'm going to tell him, can you create one more building that will be holding student information, right? So I'm going to send that message how using my GUI or my interface, that is PGAdmin, and what kind of a language I'm going to use to deliver this message. SQL, because he understands SQL. Like you guys understand English, you don't understand uh, other languages. You understand English, okay? So that's why I'm delivering the message in English. Similarly, relational database management system mostly understands SQL, but the best part of Postgres is like you understand four more language or your procedure language. One is Python, Perl, PGSQL, and one more is TCL. Okay, so so it automatically, and there is one software that he created as like a filter as for this bridge between these languages is called handler, that is in C. So something we already covered. I'm not going to go into that one. So right now I'm going to send my message through pgadmin in SQL language, and what message will be? It will be a request to create one floor, one schema for student information. So create, so SQL language, this is the SQL language, like how we use word and the grammar for English. Similarly, SQL language have keywords that act as words, right? So keywords, and these words are in English letters, so English words. So create is to create, and the grammar that we're gonna follow is the structure. So create, and the structure is table. Now I need to define him where what I want to want. I want to create not table but schema. See, now it will create that flow. Create schema student. Type. Let's run it. It indeed created. So if I go to the schema now, can I see it? Answer is no. Again, because this is GUI, this is an interface. It will have only the latest information that I requested, and I requested 5 minutes back. So that time this schema was not created. If I refresh it, that's there, right? What if somebody asks me that I need to now work is done, I need to drop. So simply drop schema. You can write schema name student, but now the thing is there's a possibility that it might not exist. So to be safer side, not to get encounter any problem, you can write if exists. If exists, you drop this one. Let's run it. I dropped it. Now let's refresh it to get the latest structure is dropped. Okay, so that's interesting. So we will create and drop again and again. So now if you run it and refresh it again, uh, refresh. See, student schema is created. Now we have one floor for student assistant. Schema for student created. Okay, now schema is created. First one is done. Second, now I want to store student information, right? And I know for student information, I want to create one room for student personal information in that floor. So that means I need to create a floor that is table, table data for what? For student personal information. That's my requirement. Okay. So again, we're gonna use PG admin to communicate with relation database management system, and we're gonna communicate with him through SQL language, and for which we have the word keywords, and then we have a grammar like syntax. Combining this, we will send our message that he understands. So we will write create table. Now this is database, right? We are connected with the database, and database is a collection of schemas, right? That means if I'm not defining which schema, which floor I want to create, it will by default go to the public because this database equivalent to the public schema. So I want to specify that you need to go to the student schema, then create dot is like dot means access into. It's like if you want to go into someone's house or in a building, what you do, you knock and go inside, right? Use that door. So this door help us to bridge or help you get into that room or into that building or get you into that door. So you go to the student, and then because you're already inside the database, you are inside the building. So now you are asking this relational database management system that go into the student floor, create one room for student STD personal info. Okay. Now he will create, but he will ask like in that room, how you gonna design, how many rooms you want, how many kitchen you want, washroom, what kind of design you want, right? So I need to give him design. So how we store the data in database is in tabular form, row and column. Row represent a complete entity in the real world, or it can be an animated object as well. And the columns represent the information or not information, but I think the correct word is detail about that entity, right? Like if I'm storing the student personal information, what kind of a detail I want to have? Its name, its age, its student ID, and then its university ID, where he is studying, right? So I understood that thing. And remember, you need to always end this command, whatever I am sending this request, because SQL is declarative language, is query based language. You ask, so every ask should end with semicolon. Okay, so this is my ask that you need to create one table, one room inside the student floor or schema where I want to hold information about student personal info, where the detail will be. I want to store the detail about the student. First detail is student ID. What is his ID, right? So before I start with the ID, when a student becomes student, he becomes student when he belongs to a university. That means the first column should be your 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 university ID, right? So university ID, it should be integer. But can a university ID null? That null means empty. Answer is no. At a given point of time, it cannot be null, because if it's null, that means he doesn't belong to any university. That means he's not a student in the first place. Because my assumption is like he's already enrolled, right? So not, it cannot be null for me. Okay. But there can be a case like in a university, there are multiple college and colleges are assigned after the students enroll in the university. So he might have the university student ID, but he might not have the university ID, like which of the university is going into. There's always like criteria that one, but usually they don't have a happen. And our scenario is if he's enrolled, he should have a university ID. So it cannot be null. Student ID, student ID, integer again, and again it cannot be null. If it doesn't have ID, student ID, that means it's not a student. Then I want, so see here, I can write stud for student, then underscore ID I can write it. But since I'm using this room name as a student personal information, that means I know it's all about the student information. So I can remove this one and I can simply write it ID because it makes more sense to me. Because when you use this tool concept again, that go to this schema, then this room, and then access this particular cabinet where I have the detail about my student. But if you write again dot student, so many students, right? It doesn't look that good. So ID. Then second one was the name. Again, it's gonna be varchar. It can be varchar, or I will write varchar. And let's say 20. And again, it cannot be not null. A student should have a name. Then age is good. It should be integer. And again, it cannot be not name. Okay. After age, what I want is address. It can be now. The problem with the address, it can be really large. It can be very small. So I will simply go with the text because I'm not sure with the numbers. And can it be null? Yes, it can be null. Sometimes student change from one place to another, and there's a time that they don't have address, and that's completely legit and fine. Okay. Now this one here. This is the table I have created. And if I execute this one, there's a problem with this one. See integer, there's a problem with this spelling. Integrate. Line number 8. Oh, see here. The problem with the name. Okay. So now let's execute this one. Table is created student. If you go here, you just refresh this one. What's the time? It's 12:42. Okay. Just refresh this one. Okay. Go to the tables. You see, we created the student personal info and table is created. Now again, I'm going to write down drop table if exists student dot student pers info. And why I'm doing it? Because right now I'm going to run the script again and again. If I don't drop it, it will try to create this table again and again. Or I can write create table if exist is also fine, but I'm using this drop statement instead of like create table if exist here. So if exists, it won't create. I'm dropping it again and creating it again. So you guys know how to use the drop because it become very much always at your eye. So for that convenience, I just writing this one. Else you can simply write create table if exists. It's gonna work as well. Now, before we move to third, let me check the value. Select from student dot stud first info. Right? Let's execute this one. Now it's a cannot drop a schema student because other objects depends on this one. Other object depends on this one. What object is depending on this one? So student, this one info depends on a schema, drop, cascade. But what a student depends on drop table if exists student, this one, create table, then I'm again creating it. But it says cannot drop schema, cannot drop a schema student because other object depend on it. Ah, you see here. Ah, this is really interesting. That's why I love to say this one. So if you see here, I'm trying to drop this schema. I'm trying to demolish the floor. What is student, right? Right. But the problem is in that floor when it was empty, I could have like we could have like demolished it. But right now we have created one room into it for storing this information. That means if I have to drop it, cannot drop it because there is something created inside it. There is one room specifically for this one. So it is throwing error that if you drop this one, you're gonna have a problem with this one. Now, how to tell this guy that I am okay to delete everything? That means if I want to destroy a flow, that means I need to destroy all the room inside it, right? That's a contingency plan. If you want to if you want to demolish uh, a building, you need to demolish all the floor. If you want to demolish all the floor, you need to demolish all the rooms. Similarly, if I have to demolish this schema that is a floor, a student, I need to demolish the room inside it before I do that. So tell him that you can destroy or you can demolish everything inside this one. I need to specify a combo of keywords that is called on cascade. And how to write it, I don't remember. Drop, use, drop, and cascade. See, so it give you hint that if you want to drop schema, that means you need to give us permission to drop everything inside it, and it can happen using cascade. So drop a schema if exists this one on cascade, I guess. Or it's a cascade. I don't remember. On is not the word. See, everything is dropped. Okay, now it is working. So if 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 there is any other room you have created in this schema or in this floor, they will also drop. So you need to write drop schema if exists student and then cascade, and that's how you learn it to Cascade is that keyword that give permission to the relation database management system or that building operator to go inside the floor and delete or demolish everything inside this one. That's why cascade is important. Okay, now what happened in the exists? So now it will drop. So now if I haven't written this if exists, what could happen? It will throw an error because right now it created a brand new floor without any rooms. And what we are trying to do, we are trying to demolish one room. Last name is Scoot Verse Info, but that's not created. That's why this is important. And then again it will create and all those values here. That means yeah, retrieving structure of Scoot Verse Info. We are good on this one. Now we applied these things, right? Not null, this one. These are nothing but constraint, like how data type is also a data constraint. Similarly, not null is a data constraint where we put this data constraint. So most of the people don't know about this one. You can simply write this as instead of like for like suppose for text I want to write, you can simply write address not null address. That's one. It is running right. So you can write, and I usually do this way. When you create a table or room, you need to define your data structure. How you gonna, what kind of a data you gonna gather, right? And then you're gonna do constraints. You can write constraint here. So this way it becomes easy to track what kind of a data you want and what kind of a constraint you are applying on that one. And that's really important. Okay. So there's one thing I always want to see. Okay. And if I remove this knot here, it will still work. Because by default, every column is null. That means emptiness is allowed. That's by default. By default. You don't have to specify. Else you have to write null, 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 null everywhere to be more specific that null is allowed. Okay. So there are only few columns out of all the columns in a table or the detail about an entity that you want to make sure that it always have a value. That's why not null become that is specific event where we need to define it specifically. Else every column is null by default keyword. But if you see here, two constraints are together, integer and not null, or null together. That means you can put multiple constraints in a single line, or you can create one here separately so it becomes easy to track. Okay, now second rule that we defined was, so how many constraints we are done so far? Not null is done. Let's go with the check constraint. I want to check if the value stored into the age is always greater than 18 and less than 50, right? So what I'm going to, I can write here, check. What I want to check that, uh, okay, let me do it. Age is greater than equals to 18 and age should be less than equals to 18 or 50. That means a student should be in between these two. And now since I'm going for constant, I will put one comma because now there's another one. And the problem is it's gonna fail, in my opinion. It does indeed fail because check act as a functional constraint. That means you need to put this into function like this. Yeah, I was right. So if you see here, I will I will show you one magic. Now this is done. Let's fourth and so every time I'm going to keep it like display retrieve retrieving data from stood source info. So this is always gonna be at the bottom. Right now I want to insert data and check the credibility of this statement. So what I'm going to use word keyword insert. So it's English like I want to insert one student information like stud. So and where it gonna be inserting, since it's a person information, I want you to insert into, since I'm already in the database. If not, you can also specify the database like university. Then you need to get into the university. You will write dot, then the floor name, that is a schema student, and dot, you will get into that, right? But let's write it student. So now relation database will get into your student, but since we are already inside this one, you can see this is created inside this one, so we are automatically into database. But let's define it. Let's so get into database student, sorry, university, then student floor, that is your schema, and get into the room where I'm storing the information about the student personal data. That means I need to get into the table stud pers info, right? I want to put it. Now I need to define one more keyword that tells you that this is done now. After this, all the values will be available. So I will write values. That means now every values. Now this is the value I want to insert. So this bracket represent one entity, one information about one student. If I separate it with a comma and add one more parenthesis, that means I'm adding two entities into this table. Okay, right now I'm going for one. So in this bracket, this two brackets open and ending brackets represent one entity. That entity is a student whose information I'm going to store into this table. So what kind of information I want? I want is university IDs. Let's say one. Then I want is personal student ID. Let's say one again. This name, suppose I write it down Nitin. I'm enrolling myself in a university ID one with a student ID one. Right? The third thing that I want to store my age. Now, suppose my age is 18. Right? Okay, suppose it's 18. Then my address, since it's a text, I can have a value, right? So I will put default. So what is the default value you have told for this one? It will automatically come. And the default value of address I told you is null. Default value of an address is always null. Any of this data type, if you don't define a specific rule and it does not receive any value, it automatically takes as null. Okay, so default gonna be null. Okay, so address near the address. See, what see? Characteristic. Syntax error. Address. Text. Is it possible that because of this one, I haven't defined null value? Yep, but cross references. University. Okay, cross database references are not implemented. So thing is like it's already inside the database, then I cannot use university. Is this spelled say UNIVER? My spelling itself of university is incorrect. That's why it's happening. Dude, let me rename this one. Let me create. I cannot. Dude, this is embarrassing. But yep, see, it is trying to access university database, but I am inside university. So now let's go into very city. Very city. Let's run it. So null value came here. But I thought like if I put like default, see, I was right. I was right. So if no default value is defined, it automatically take at default now. So this default null is attached with everyone. In case nothing happen, it will happen. I will run it again. It will be null. Okay. So not so default null itself default everywhere. If you are not defining other constraints. Okay. So I'm pretty much good. I'm pretty much good now. So I got university ID, this ID inserted. But that's not the thing I want. I want to check whether if someone, a real student, send his information and he mistakenly put 1,000 year old or negative 100 or 0 or 17, will it take? Answer should be no. It should not take. It should drop. So let's change this to 17. Now it failed. See, notice, leave it. New row for relation. Relation. So I told you that row, the table is nothing but called relation because in a flow you keep all the people or entity that belong to same category or they have like relationship one another, right? And then you created multiple rooms for each entity or which each group, right? So that's why it's called relation as well. This while is the check constraint. And check constraint, see what is the check constraint? This is the check we have created, right? But is a check constraint student pers info page check. This is your floor or schema. This is your room or the no, this is student pers. This is your room, right? Inside that floor. Then this is your cabinet where are you storing or your attribute or detail about the entity, and the check is that constraint. So what happen if you are not defining the constraint name? The system or relation database management system automatically give this a name. And if you want to give a name by yourself so it become convenient to track back, you can simply write I want to define a constraint, and you should be doing this one because it give better texture or the syntax to the whole system, a meaningful syntax to the whole system. Syntax, so constraint, and now I want to write the name of constraint. I can simply write, what can I write? Again, I can write the same thing that he wrote here, but I will change a bit name, then I will make it right. Self. I wrote self just for understanding. If run, see here, it got self. That means you are right. Okay, so you can write student age check. So you wrote like student is my schema. Then this is the your table, personal table, right? This is your schema. Then your detail about that entity and where what's the check you what the constraint you're trying you're trying to put the check. So you can put it, or if you don't want it, you don't want put it, you can't. You simply remove it. But sometimes it's good to put it because you can simply access to this one in future if you need that one. It's easy. That means now it is running fine. So my rule is implementing properly. I can put C for 50 as well. See, age is coming properly. So that means we are good with constraint. We are good with the not null. Now unique. What is unique? Uniqueness define when the value is one in one. One of its own self, right? Very unique, very different from other. But now suppose what I can say. Ah, Can university ID be unique? Answer is no, because there can be multiple students who belong to the same university, so university ID gonna repeat. Can this ID be unique? Answer is again no. Problem is with this ID, because we are looking from one perspective, look from other perspective. There can be multiple university, right? So suppose University Texas, University of Northern Carolina, University of New York, Jersey, right? New Jersey. So there can be multiple ones. Inside those all university, the ID roll number one or the student ID one can repeat multiple times, right? There can be a person with ID one in New York. There can be a person with the ID in the university in Texas, right? That means these two individually cannot be unique, but when we combine this together, they will be unique, right? That means if I have to create a unique key, a unique way to identify a record in this particular storage, or in this particular collection of a student, that means I need to define a unique. So I can write unique is also constraint, right? So constraint student first info. And right now, am I applying on this one? I'm applying on uni, or since it's a combination, I'm not putting it this one because that will automatically come in this side. I will put only unique. But it can have more unique. So write it down. So is ID. That's ID. Okay. UID. Uni IDs. Okay. Info IDs. Unique. I'm creating a unique key. I'm trying to make sure that the combination of university ID and the student ID is a unique in this table. It cannot be repeated. It cannot be allowed to repeat. That means in a university, one student will have one ID. It cannot have been duplicated. But this student ID can repeat again for a different university. And for different same university, this can be repeated with other university. But as a combination, they should not repeat. Did you get my point? If not, I will just make you understand. So rule is, well, there is a university A, there is a university B, and there is a university C. Okay, his ID is A. ID is A, B, and C. Let's say. Okay, ID I'm putting is as character. I'm putting cat one. Okay, as a university ID, we can take it. Suppose there's a student here, there's a student here, and there's a student here. If I'm working here as administrator, obviously I will tell him that's a student one, that's first enrollment. If I am an administrator of university B, why should I take care of A and C, right? I am just concerned with this one, and this is the first student that came in, so I will give him roll number one or student ID one. Same for this one. Now see, this student ID one in this whole system is repeated three times. Can it be unique? Answer is no. Now your college ID or university ID. This is one, but the number of record, now here there is a second student who will have this A. That means it's repeated twice. If there is a third student came, he will also have university IDA. It is again not unique because it is repeating for multiple students from the same university. But the combination of university ID and the student ID is unique. So if I pick this one, this guy, it's ID. If I have to represent, if I have to give him some information that uniquely identify this one, it can be his university ID C and that's individual ID one. C1. Is there any person with this name? C1? No. That means this combination of university ID and student ID can be unique or can uniquely identify a record. Correct? That's why I can define here is constraint your schema your table student person info where I'm ID I'm creating unique key. I'm putting that constraint that for this combination only one individual should exist. So I'm using unique. And what are the detail or attribute of the entity that combine together uniquely identify this one? First one is uni ID. Second one is ID. Let's run it. Okay, there's a problem here with the brackets. Uh, okay, I haven't defined what kind of constraint I'm applying. I'm applying unique constraint. Okay. So this too is how we create table name. Similarly, here for constraint we don't write create. We simply write constraint name, and whatever the constraint we are putting it. Okay. This is itself is a constraint like create. Now if I run it, syntax error on the constraint. Uh, constraint is right because I ran it for earlier, right? This one. Okay, that means this doesn't follow. Okay, if I run it again. See, that's why I hate this one. Sometimes it happen like this. You need to refresh it again. It doesn't make sense. Dude, that's why I got confused. Like there's instances where I find the code is right, but when I modify it and run it again, it failed. But when I do it again, it passes. There's a problem with the cache or something. It is running the previous code, something I don't know. So now see here. Now in this particular storage, in this particular table, two entities of a student personal information cannot have same value for combination of university ID and ID. It should be unique. Okay, let's try to do and check this one like comma. I will first I will put one proper value. So in a university one again there's another enrollment of student number two, that is your Robert. Okay, okay, he created. But because now there is a third one. So Raba. Okay. And now the problem is like the administrator made a mistake. Both came in the same time. He provided the information or the student ID to do. Is it possible? No. In the same university one, they cannot exit one more student with ID two. That's a logic, right? That's a completely valid logic. And what happened? It showed that it is not properly. It cannot allow to exist. Why? Because because there is a duplication that violates the unique record constraint or the rule. That means I need to give him another ID. Good ID. One, two, three. Voila, is good. We are good, right? But if you see here, mhm, it's a, mhm, we should go multiple ones. Hmm. Okay, but age is again 50-50. Let's change their age to it. Why I'm 50 years old? I'm 18 years old. This guy is 50 years old. She's she's also 18 years old. Now this is the that means unique is working fine for me. And why it is fine? Because of everything that is happening. Now the biggest problem that we already saw. Let's say we are not sure. See, in this scenario, we were sure that the student who came, it always have university ID and student ID. There's a possibility that they are coming to inspect, they are not enrolled, but they are coming to inspect and we store their ID. That means null is allowed, right? Default null. So this emptiness means as default. Okay. Now two more student came in the university number two, and their ID is one and one, and their name was Chris Crystal. Another name was Babe. Okay? And he is 22 years old, and she is 24 years old. If I run it now, why the problem? Now, what happened in the university number two? This guy didn't check that there is already a student with rule number one exists, so that means it violates the rule of uniqueness. Now, two. Now it look good. Okay, that means at given point of time, everything is fine. Now, if you see the student Crystal and student me Nitin have the same ID, student ID one, and that was the reason we cannot take the uniqueness for an individual column. We need to, for uniqueness simply means you need to have a combination, or you need to have a value that is unique for that entity in the entire table or entire room or entire data set. Okay, here college and student ID combination makes sense rather than university ID or student individually. So that's something you will learn more the more you do it, and slowly you will get the hint. Now let's get back to it. Now what happened? They realized that these two guys, these two, Grappa and this one, they came to check the university, but they are not enrolled in the university. They are, so they clear the exam, they got the student ID, but now they have to decide which university they want to get into. So this is default. Okay. So I run it. This is allowed because this is the scenario and a legit scenario as per our understanding. Okay. So student pass the exam, they got their student ID, but the university, there are multiple universities. They need to define which university they want to get into. You can define it this way. Or you can define a student Krista and Babe clear the exam. Now they have not enrolled in any of the university, but they have they are gonna do that one because they already cleared the exam. So Krista on this one, like initial phase of admission. Okay, so now this is two are now it makes sense to me, right? Now, if you see here, what we told you that the combination of two columns for any record for any entity, that is university ID and your personal ID or your student ID, should be unique. But both have the null values. Both don't they look exactly same? But why it is allowed? Why not only one record with null null? Or why doesn't it throw the error that there is a duplication? Because null doesn't represent any value, right? I will write down. This is very critical. Most of the people get confused. Even most of your uh, most people with the high experience got confused that null never represent any value. Okay. For example, if there is a coin, it's just a metal. Until unless it has written one some drawing and issued by a government, then its value become something you can buy for a value of €1, right? Before that one is just a metal piece. Similarly, the null represent nothing, nothing, empty, missing, right? Since it represent nothing, emptiness or something, and what the definition of unique? Unique means non-repeating. Non-repeating means unique or one value, one record, right? One value. Does nothing represent any value? No. So how you can compare with one value, one nothing with another value, one null with another null? Okay. We are saying when we use comparison operator, when we are saying we don't repeat this one, that means we are not repeating values, right? But null represent nothing or no values. Since it doesn't represent any value, how I can compare one null with another null? Can we compare it? No. That means it bypass this logic of uniqueness. And that is why they are here. Because they are not repeating, because they are not value in the first place. So they cannot be compared with the logic of same value cannot be repeated. These are not values in the first place. How you can repeat again as a value? And that's very critical. So in a table, if you are saying a column, a group of column, or any derived column, any of the case is unique. That means one value, one record, except except multiple entities can have null values. because null represent no value, so it is not repeating. It is not repeating values, right? So they are unique in themselves. And this is the reason we need to create a logic, because now the thing is like I cannot go with this logic if it is not an if somebody even passed the exam. This table is for student personal info. That means it must be assigned as student ID and it must belong to a university. So this case cannot exist at any given point of time. That means we need to put it here for not null, not null. Now it will throw error, right? It again throwing the error. That is null is not allowed. That means you need to assign he teach. So Crystal choose college to a university to, and Babe also choose the college to a university to. And here it was assigned with the student ID 1 and 2. Now if we run it, it's running perfectly fine. And that's exactly what we want, right? Now that uniqueness is done, we got the unique values, everything looks so perfect, very good. But what our logic was that, see, why we were using a unique value? We were using unique value so an entity inside a room or table can be identified, right? If I cannot identify one individual in a table, it becomes havoc. I cannot understand how it is happening, but it's happening. So for this level, uniqueness or the unique constant was good until it allowed now. Because null means no values and uniqueness means not repeating value. And since it's no value, that means it cannot come into that non-repeating thing, right? So all the nulls is allowed. That means for null thing, I cannot identify the columns properly now. That means I need something that have unique constraint plus not null logic. And this will become now it in real sense become one what was that? One value, one ident, one record. So this value will help me to identify record individually in that particular table, right? This one. And this is where we lead another constraint, primary key. Primary key, what it does, it is this same thing. Only the thing is, a table can have multiple unique constraint, but there will be only one primary constraint. That means one value, one record. Using that value, I can identify individual record. Okay. And if I apply this to any column, combination column or a drive column, it will automatically take care of this too. I don't need to define it again and again. And using this one, and now you're gonna ask me that, Nathan, if that's the case, why can't we simply use this one and not write this thing? You can do it. But the problem is like if you read someone other code and there are 10 or 20 primary key defined like this way. The problem is how you know which of those you can use anyone, but which one you should use. Which one you should use. Despite the fact that every 5 or 10 constraints are unique, but which one should you use? To get that flag that this combination of unique plus not null logic, there can be multiple. I will define one flag that this is the one you should use for your searches, for your deletion, updation, everything. Okay. So primary key become that flag that you should use this for identifying the column. There can be multiple other, but use this one as a primary one, primitive. It should be primary. It's for that flagging we use this primary key, nothing else. Perfect. Now there is one great thing that you should know about this one. When a unique or primary key is created on drive column or a combination column or single column, at the back end, a B tree is created for faster access of entities. in the room or in the table. Okay, both the ones. So remember, if you created one table and then you inserted values and define a primary key. Whenever you insert a new primary key or you update the primary key, it is not just making a change here. It is also changing in this Brady indexing. So it's a double way. If you are doing the last table, you are doing again insert. It is taking more time because it is not just inserting and updating. It is also updating your B tree indexes. So now we are good with unique key, primary key, now foreign key. Okay, so now I told you clearly, right? Here is so this is university A, this is university B, and this is university C. On this table, the information about the student data, where each university have multiple students. Now here they have ID, then name, then age, then address. This university ID they have, that is B here, right? We wrote it B or one or two, whatever it is. But is it legit or not? Who gonna tell me that? That somebody put that university ID is to university ID B, whatever it is, in that flow, right? How I will know this is right or not? That means I need to check if the information about this university that it is right or wrong. That means I need to create one more table where it will have university ID, then university name, then establishment year, then address. Fourth thing. From there, I need to check whether this B exists or not. If not, that means there's a problem. And that is right. If I'm creating this structure, first thing I should create a university, and then I need to create the corresponding students into it, right? So now let's create student university table. So now the student schema is there. University is here. Schema is a student. Now let me ask you, since is a student schema, this is a flow for the student. Should I keep this in a student information or should I keep it in a different flow? I think different flow makes sense. That means I need to create one more schema, or I think the schema. This university schema. So this is a flow for storing the university related information tables or related tables. So I will write it. University. And since I'm dropping university, there can be multiple table inside it. That means I need to put cascade by default. Okay. And I will create university. Right? Your database university. Dude, I feel ashamed all this one. Okay. So this is done. This is done. Now what I have to do, I need to this is a schema. This is the student table inside student schema. Or you can like better schema, schema, uh, student, then table, stud, first, info. I would look for the schema, student. schema university. Okay, now let's look. No, student. I'm in the university. Inside the university floor, I'm going to create a university uni info, right? How I created a student person info. I'm creating one table for university information inside the floor of university or the schema university, right? So first of all, I will drop this one. Drop table if exists. And what's the table name? University dot uni info. Right. Now create table. Create table RDMS inside the schema uni was now I'm writing again university. University. Why university? Okay, so create table inside the floor university for a room or storage of uni underscore info. Right now, I need to design this one. So inside this one, I need couple of things like first I need university ID, right? Uni ID integer, and it cannot be not by default. But what less then name is varchar. It's gonna have like 100. Then establishment year integer, and it cannot be not null because they should be established sometime, right? They should know their university itself. And then address that can be text and default and that's not needed, but I love to write right now. Alright, you can simply remove it. It's the same thing. I'm just keeping it. Okay, and it does look good. Let's run it. So drop table if exists university table error. That means there is a problem. Okay, I think error is coming from this side because I messed up here. Yeah, I totally messed up. So I just wrote everything inside the this one constraint. Okay, so this is the table detail data structure, not data structure, but table structure. Table structure. So here I'm writing table structure, how my table gonna look structure, or how I'm going to receive the information about the student. Now I need to start writing constraints. What kind of constraints I want? Firstly, I want the university ID primary key, right? Because I want one value, one record, and that is university ID. Because for every university, there will be only one and only one ID. Okay, so I will put constraint, and the constraint name is your table name uni uh towards uni info. Then I need a primary key. So see, key is like primary. Now I need to define because like check this goes into parenthesis vector because this is your function, and I'm going to use uni underscore id. It should work. Okay, now again the same thing. Constraint this one, but where is constraint? This is constraint, constraint name, where is constraint? That's why you keep on doing this one, dude. I make a mistake, everyone make a mistake. It's just you need to see and learn how to identify this one. Rule number 33 here. If you know the structure, you can simply like constraint, constraint name, then the constraint itself. constraint, and then constraint itself, and then constraint values. So is a primary key, this one. Right now I'm using one. I can simply write the same thing here, like not null, comma, this one. Now thing is, since my university itself become a primary key, do I need not null here? Answer is no. You can simply remove it. Simplicity. Because ultimately primary key is a combination of uniqueness, a unique key constraint plus not null. So I don't need to define not null here. I can simply remove it. Now it looks beautiful. Now right now I'm working on select star from university dot uni underscore info, because I'm interested on this one. Okay, now yeah, I know there's two group of student in university one and two. That means I need to insert two data, right? So now here schema student, and then table stud first info, and it's insert data. So I'm pretty much done. But I know before I even insert the data into this one, I should be inserting data into university, because one and two is not defined in the university table. They should not exist there. That's the basic rule, right? So right, uh, insert into uni. Okay, let's write it down at the bottom since we are following the structure, right? Because it will give you one more understanding that I want you to guys have. So insert into university, and what is the university? Insert into university dot uni info, right? And I will put values. I'm going to put two entities, okay, for university one and university two. What is the one? I need university ID, that is one. Then name, uh, University of California. Establishment year 1980, and address default. I'm not putting the address at the moment. Is the university two? That's the Uni of Florida, established in 1990, and default. Default is null. Now, if I run this, there's a problem. University, line number 46, 46. Okay, values. Uni info does not exist. Uh, wait, failed. In line number 46, let's go to 46. This is the one. Insertion is failing. Relation university. See here, what it says does not exist, right? Uni information, I know it exists, okay, because I'm creating table. But this is schema, university, exist. But if you look here, it's not highlighting, right? That means there's a problem. University, dude. I I'm going to try out of. See here, everything look good. So university one, university two, and this is that. But, you remember what I told you, the logic that if there is a student, okay, he have university one, his student ID is one, his name is Nathan, his age is 19 years old, and the address is this one. This is one entity that I'm going to store into database university, in the floor of a student, that is a schema. Inside the room or the storage, student stood words info, right? That's the logic. And it does look good. The problem is, this is good, but university ID is one. Does a university with ID one exist or not? That means there should be one more entity somewhere that holds the information about University ID 1 as the name University of California with the establishment year 1880, and the address is null, not this one, empty. If it exists, that means this is a legit information, right? So this kind of a relationship, one value represent another entity, not the same entity, but another entity, not similar entity, another entity. This kind of a relationship is called foreign key relationship. Okay, or this is also called referential integrity. Referential integrity. Integrity, what is mean? It's mean rule that if there is value one or university ID one, that means there should be a university with ID one should exist at given point of time. That means we need to create this referencing. So this referencing when one ID defined here should exist in another room or another place or another table. This rule is called referential integrity, and we implement using the keyword foreign. Let's do it. That means in my table, student personal information here, right? I need to define one more constraint. Constraint student first info. I need to define a foreign key. Foreign key. That's the foreign key I defined it. Okay, and it can be multiple foreign key. So let's keep it foreign key, and it should be foreign foreign key. Okay, I am defining a foreign key on uni ID. Okay, references. Now I'm referencing, right? It should referencing means it should exist into. I need to give him a table and write, right? Referencing means you go. Referencing means go and check reference. This is a reference means go and check whether this table and this record exists or this record exists or not. That means I need to give him the room and the ID of that individual. That's why I teach you the primary key. If there is no primary key, there's so many entities, there's so many university details, there's so many university and entity in that room. How will I identify which one is it? Right? That means the references should go to a primary key, and we define it a primary key here, right? This university ID. So it should go to table schema university, and inside this schema the flow you need to go to the room or the table that is your uni info, and inside this one you need to check for the particular detail. Okay, in this table look for a particular detail that will identify that object, that uni ID. Okay, let's run it if it's look. Okay, so you now it throw an error, relation university info does not exist. Okay, that means this one, there's a problem with this one. University, and this says uni info doesn't exist. Okay, it does exist, and uni ID. So let's copy paste it and let's see. If I run it, we say relationship. So when relation says means table, this is exist, and it indeed the case, because if I am referencing, that's why I choose this one. So you see, this record will not is not a legit one if the university ID as an entity does not exist, right? So that means that entity should be defined first. That means the table structure should be defined first. So it should be in a hierarchy of when university is created, then the student is created. And that's why I did this up and down. And I didn't number this one. So if I put this one and do it here, and similarly, actually here it doesn't matter because you are just creating the flow. Any flow can be created anytime. So it doesn't matter, but you should follow this hierarchy. Okay. Now that error is gone. Now error is insert or update on the table student violates the foreign key constraint. See here, it violates the foreign key constraint. That means this is good. Why here? Now see the same thing. I'm trying to insert the students for university 1 and 2 when when the table itself of university where the university 1 2 doesn't exist because the table is empty right now. Here, before it run, let's run this one. Oh, it will throw an error. That's the problem. Let's see if it does show me the okay, did output? No, it doesn't show. Okay. So the same thing. If my student have a university ID, then university information entity should exist. Problem is I'm trying to insert group of student who belong to student university ID 1 and 2 when the university 1 and 2 doesn't exist. So what we need to do, we need to solve this position. And that's how it like first university exists and the student come this hierarchy. And this is hierarchy we are maintaining through this one now. We are getting the university details. We are getting everything. So this is called your referencing using primary key and foreign key. So foreign key, there can be multiple foreign keys, but there will be only one primary key. There can be multiple unique keys, but there can be only one primary key. Foreign key reference to a different entity, right? That means that entity, that structure, that schema should exist first because it's a hierarchy, and then it is driven to the other ones. So we have covered nulls, this primary key, foreign key. I think we are done. Only this one, dude. I need to read this thing. Okay, dude, you remember now. Now this is the thing that we happen. Now what will happen if we update and delete, dude? It's taking more time than I thought. But I'm learning more than. Now let's go for fifth. Now if we delete the delete, okay, let's delete. Now if I delete the university when something happened, they got into scam, something that was a scam like paper shell company, and it got destroyed, and I need to delete this one. Do you think it will allow me to delete all the student record in this university? Let's see. So to delete a record you or multiple record, you need to use the keyword delete. Simple as English. Delete a table. This one. Delete record from this table where I'm putting a where condition where because if I don't do that, it will delete all the records. So I need to first select the proper record that I want to delete. So delete in table name where uni ID equals to 1. But is it right? I even don't know about this one. Okay, so syntax error, delete. I need to check, dude. That's why I told you that is been used. I think we will go to PG exercise, documentation, data manipulation, and we will go delete. So delete from, like select column from, similarly delete from this one because here delete star from this one. I think I should throw an error. Yeah. Now delete now. See here, what it shows, update or delete on table UniInfo. That is our parent table for student personal information. Violate foreign key constraint. This one on the table of this one. That means when there is a referential ID here. So when this case happen, right? That's why I want to teach you this. When this case happen, when there is a student which depend on this one, this. If you drop this one, when we drop it, no, because they are linked. Naturally, we can't do it. How the same thing that happened for your schema, right? If I have to drop the schema, demolish the schema, firstly I need to demolish, give the permission to demolish everything inside it. That means I need to cascade. Okay. So I need to give a permission on cascading if there is a foreign key concept. So let's go to the schema. So this is a primary key, right? So I think I need to write cascade. Cascade. On delete. No, here, not here. If my primary key is deleted, I need to tell my child what he need to do. So that means I need to define the child, right? So constraint here the primary key on delete cascade, right? So I'm giving it power in case somebody delete his parent entity. You also delete this one. No need to keep. See, university 1 and 2. Let me. This is gone. Okay, so first delete is working. Delete from university name where help you to filter out that record you want, and you are deleting this record that is filtered out, that is university 1, so it will have only university 2 left. Now let's see here, later run again, and that's why I drop and recreate. See, earlier it was one student university 1, right, for student 1 to 3, and it is gone on cascade. It is working. Let's remove the cascade. Okay, now on delete I am doing cascade, whatever it is doing you remove it. Now I don't want to do it on delete. If somebody is deleting it, I want to set it information as in set null. Okay, but the problem is, notice student error, null value column university ID is not allowed, right? That means here, what I did in the schema, what I told that if somebody is giving me information, the student personal information, university ID always exists. But now the scenario is if university is deleted it in the first place, go and gone. That means it can still exist, right? But I want to put it as null. That means here this cannot be allowed. And I run it again. See, now what happened? All the university is being null. Null means empty. Now, what is the problem with this one? At given point of time, I'm not sure this student for student one and the name Nitin, it is belong to some university ID one that was deleted, university ID three that was deleted. I'm not sure, dude. I'm really not sure. In general cases, we delete this one. Okay, we delete this one. Or we can set some value, say 10. I think I need to check on delete. How to do that? On delete. Uh, SQL foreign key on delete. Set a value. Foreign key constraint on a bit on delete. SQL foreign key constraint. I think it should here. Set a value foreign key. Can I find it? Set foreign key That's why I use cloud. Uh, because they are literally faster. Use cloud for free, dude. I just want a query. Why you are even doing this one? Okay, so SQL foreign key on delete set to value 10. So it should be on delete set value something set to dude set null and set I was set to 10. Because it's an integer, it should be fine. Syntax error. 34. There's a problem with this one on delete. What is say department? Ah, got it. So we cannot do this way. So we need to do it in a way like set default, set null and set default. What will happen? It will go here. It will run here, and it will put null values because here in the schema, when you don't define a default value will become null or empty, right? But I don't want that. So in case something happened and due to the on delete one, I deleted it. So I want to put a default of 10. Now it will have 10 value. Hmm? Where I define unique. Oh, I defined on the wrong place. I defined yeah, because I'm making the change on the student information, right? So if someday somebody deleted information about the university, then the student for those university should have value 10. And I set to 10, set default. Now the problem here is there is no such record in the university where it's done because right now it is still following this logic, right? So if you want to put a default value, then this default value should also exist in your primary key. And this is the beauty that when you play around, that means here university ID 10 for uh what I defined for this one, not no, a schema. Okay, I can put a null because name is not. So I will put default. Default. Say 1990 default. Not this. So I think establishment here can also be, let's put it default now for that ID 10 here. No, execute. Syntax error. Why? Because it should be like this. Okay, now 10 exit, and for university with the 10, what is the value? Or everything is null. So you can do this way. If you want to put a default setting, then you, to be very frank, default is very bad. Just set to null. This is far better. Cascade is done on this one is done. Set is done. There is two more. One is action, one is restrict. So in no action is like if you start a transaction till it is committed, like begin, then you run multiple statement and then end. This won't throw an error until unless you play with, you have already updated the value based on your requirement. Restrict is like when it is executed as a value, moment it is executed at that one, it will check for the relationship, how it does check here. And if it happen, it happen. Like if it doesn't exist, it will throw an error. That's so no action restrict is done. Set default and set null is done. So now I think I should do for restrict. On delete set no action and is restricted. But what is this error? Update or delete university ID restrict the foreign keys. This one. Primary key reference from this one. ID is different from this one. Okay, now what happened when I deleted it? Restrict. What it mean is I can't delete, but it's same as not putting this one. Okay, can you check what is right? Detail is this one is refers. Either update or delete in this one is violate the restrict setting of foreign key or this one. Now let's remove the restrict, and I'm not putting anything else, right? On delete. On delete. Foreign key constraint on this table. This one is referred. So right word on delete restrict this. Update and delete violate the restrict settings of foreign key constraint of this one. So is it possible that restrict on foreign key is used to allow deletion of parent info if and only if there is no referencing to the child table. Yes, exactly. That's precisely on delete. So on delete this one, how it behaved. Delete from this one. Log allowed no employee refer to 99. Department employee allowed on delete restrict. Okay, and error cannot delete update and remove because a foreign key constraint failed. Because there's an employee with this one. I was right. So I guess on delete restrict is same as not putting anything. Okay. Then see, so a student will exist only in a, if there's a university as an entity exists, right? In case I delete or update this value, okay, there's a relationship between these two. That means this will be affected. What I can do if I don't define anything, what will happen if there is a value here for this data? Because this will exit first. That means this transition won't happen. Delete and update won't happen, right? So it's like on delete or update restrict. It's same as restrict. If you put or not, this gonna be by default. Second one is no action. So there is a statement where you can run multiple statement one by one, and end of this one, then you can commit. You can start with begin. It won't it start executing, but it will commit the value at the end of this one. So if you use no action, that means in this statement, you can write everything until the commit. It won't perform any action even when you delete this one. Okay, but if it is restrict, it will automatically throw error here. Like this action is not allowed because there is already an entity here. Here, what happened? You need to handle the case that there should be no orphan here. So restrict and no action ensure that there is no orphan here. Then there is two more, that on delete or on update set default or set null. Okay, again, null is nothing. Okay, that means it can hold a value. So there should be a referencing to this one. So what primary key and foreign key says, that a foreign key should exist in the primary key. A referential integrity say a foreign key in a table should exist in a primary key of another table, right? That it says. But the value should exist. But if you talk about if there is a null here in foreign key, is it a value? No, it is not a value. So so it bypasses again, right? It bypasses it because what it says, it goes here, it compare the values, compare value, compare value, compare value, compare value. All the values among all the values, okay, it will fail. What I want to say, this relationship for an entity fail when he try and go there and search a value and it doesn't find a single value. Okay, that means it compare false, 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 false. So when everything is false, then only this the entity in this foreign key entity here and foreign key doesn't make any sense here. That's why then it throw an error. But what with the null? Null means no value. You cannot compare here. So everything will become null, 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 null. And what this statement say foreign key, that all the value that we compare should be false. Then only it will fail that existence. Does it have a false? No, that means it's false. So it's like negative true case. I know it's a bit confusing, but it is what it is. So remember, in SQL, we try to find a Boolean value end of the day. For example, primary key and foreign key, we see if all the values are false, that means it fails the 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 referential integrity. But if the value is null here, because it's a primary key, it cannot be null here. In the foreign key is null, everything is null. Does it fail? No, because it says everything should be false, not null, no value. So it passed. I know it doesn't make sense to me this one, but it is what it is. We can't do anything on this one. This log is not exactly might not be the same way. The structure might be different, but no one remember. You should follow this way, or you can have your own way as well. So the thing is, so on delete restrict is same as not defining anything. So is it a default setting? Yes, I was right. So on delete on update restrict is the same and same with the update. So not much detail, but if I go here, delete date previous. So update table set then the value, and for which table you want to do, you put the condition like how it used for the delete. I think tomorrow I can complete this one. I'm not going much into this one. But yeah, pretty much done. Tomorrow we're gonna look into the structure, so I'm not telling much. I think I will drop for today. So today I think we learn everything. Only thing that is left is I don't know. Do I need to exclusion constraint? Exclusion constraint ensure that if two rows, two entities are compared on a specific detail of the entities or column or expression using the specified operator, at least one of these operator comparison will return false or null. Why it is used? So create circle, adding an exclusion constraint will automatically create an index on the type specified in the constraint declaration. So create table circle C exclude using just what is this? I don't know, dude. I never use it, dude. I think you can skip it. I never use it. It might be useful in the future, but I never use it to. Okay, now let's see what it has to say. SQL has a more powerful generalization of unique constraint. Instead of checking equality, they allow you to define custom condition using operator. Eh? Index. Okay, so is a more powerful generalization of unique constraint. Okay, exclusion is the specific constraint or unique. Unique, no two column can have the same value. No two column can satisfy a condition or overlapping range, same circle, etc. Condition. Oh, I now I got it. So uniqueness can be defined. So when I use the unique operator is simply column combination of column or a drive value, right? But if I have to write expression, it cannot be used using a unique one because I need to use the columns. No two column can have the same value. Okay, it does say no two unique value columns have the same value. Mixer create table operator. Now exclude using index method. Column one operator, column two operator. So no overlapping of the room. Table this one. Room with equals to using just room with equals to booking with and blocked because insert into booking room value is such a key value exclusion because in the room one uh, create table then I am using one constraint exclude using index method column one with operator column two with operator. So what's column one equals and booking with overlapping date. So one two one allowed can be allowed date range. But this 2001, so there's a customer that came in, there's a room ID that is booked between this two date. Then number two is booked for this one. Then number one is booked again. Then to 15. Then one book I'm trying to put between 3 to 8 and it conflict with the key wireless exclusion constraint. Conflicting keys. Okay, it is more freehand. So same room. Ah, makes sense. But I need to read more on this one custom. I think I should make it separate. It's fun. Like so, no overlapping employee scheduled is the same. But here I'm using just, and somewhere index method. Okay, what kind of an index method I'm using? Okay, so I'm using just. Here I am again using just for shift TS range. Here I use date range. This is timestamp range. This is date range, and this is timestamp range. Okay, unique constraint. A unique constraint is a special constraint. It's a special exclusion. That's a custom. This is specific to the We exclude using B tree. Yeah, unique is B tree, and this is your just B tree. Code with equals. Oh my god, this is interesting. Range geometric type, B tree, scalar values, okay, equality. And GSPG is geometrical network type, no duplication. Check. Foreign key representative. Good, I think I will read more into this one, but I understood one thing here. One, when there is a scalar value, you can simply use column name, the index I'm using it, then the column name, then with what kind of operation you want to involve equity. That two values should not be equal. That was used. But if it is a range, date range, timestamp range, or geometrical type, whatever it is, or full text, then just is used. So just index is created here. So exclude using just index, then column name with, and if it's a range, you will use to ampersand. Just yeah. So what it does, it will check there should be a combination of this two should be unique value. First one is room ID and the range. And when I say this one, just so it should be, that means it should not be, rather than this one is, rather than you being same value, it should not be overlapping value. The range should not be overlap. One is same, equity is the same. Second one is the range overlap. And here they are checking for range overlap. Is there a range overlap or not? If not, then fine. See, it's the same date, but the room are different. Is the same room, but different date. They are not overlapping with one. Same room ID is free from 5th, then it booked to 10:15. Then 15 to 6 till 15, so it cannot take 15, it should start with 16. So overlapping, it check for the uniqueness of overlapping. So room ID should be unique with the booking range. Then we use the gist. So unique constraint is a specific case of exclusion constraint where I use only one number of columns with equity sign. There is a scalar value, no date range or no other things. This is really, 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 really far more interesting than I thought.